using rate reasoning to convert within measurement systems. So your objective today is to write and use equivalent fractions or conversion factors to convert units within a measurement system. So today we're going to convert customary to customary and metric to metric. In the next couple days we will convert from customary to metric and back and forth. Okay?
Does it say that I finished the 6
I don't know, Jaden. This is the lesson day, so you're just gonna have to sit and hold tight and watch the lesson.
Sounds good.
Okay. Now tomorrow when we get ready to do the on your own, if you're done, I'll let you go. All right. So Milo is making 1.5 batches of muffins for a bake sale. If each batch of muffin calls for 1 3/4 cups of flour, how much flour will he need? So does anybody have any ideas of how would we solve this problem? He makes 1.5 batches.
You could start with saying that since he's making 1.5, he could take the 1, so he'd have 1 3/4.
Yep, so we know that one batch is going to use 1 3/4. Yep. Or we can say 1.75. We do know that. Yep. And then how would we?
We would divide 1 3/4 by 2 to get that, and then add those two numbers.
Okay, so 1.75, we could do it that way, and divide it by 2, so that would be, okay, so then 2 into 1.75 would be 8, is that right, 16? And then 7, which would be 14. So half. Yep, so we could do it that way. So 1.75 plus 0.875. So we would get 5, 12, 15, 16, right? So we could do it that way. Oh, my screen is frozen again. This is the only class that I'm having issues with that.
Why did you put it into decimals? Is that like... Sorry, I was a little bit late to class. Is that like what we're supposed to be doing?
No, I'm just showing you a way to do it. So you want me to do the fraction. I can do it the fraction way. So how do we, Aiden, how would I take half of 1 3/4? What would I need to do?
Well, you would take 1 3/4 and you would convert that to a fraction greater than 1, which is 7 over 4.
Mm-hmm.
And then you'd have 7 over 4 divided by 2 over 1 if you made the 2 a fraction greater than 1.
All right.
And then reciprocal would make it 7 over 4 times 1 over 2.
Yep.
Which equals 7 over 8.
Yep. Absolutely.
You add 1 3/4 to 7/8.
Yep. Okay, so now what do I got to do? I can't.
You have to convert the 3/4 to 6/8.
Yep.
You're adding.
Okay, I'm following you so far.
That would equal 2 over, and then 2 and 5/8.
Yep.
That's how I would do it.
Okay. And I'm fine either way. Absolutely. So either one of
I'm a
those.
little bit late in class. I didn't know if that was like what we were doing today.
Nope.
Was with decimals.
Nope. No. Well, you know how to do decimals, though. We've talked about decimals, right?
Right, I just find it easier to do the fractions.
Yeah, we've already added, multiplied, decimals. We've done fractions, so we've done. So we should be able to do it either way. Okay.
I'm gonna refresh my page because the screen froze again. Wait, never mind. It's good.
Okay. All right.
Oh. It always just like lags whenever somebody else in the like class has their like mic on.
Yeah.
That's like probably the reason why.
Yeah, I don't know why. So if the screen is still freezing, guys, you're just gonna have to do your best, and if needed, you'll have to watch the video later on. Okay, I don't know why it's freezing.
Okay.
Okay, so because if I continue to go in and out, which I can, that's just going to be a pain. All right, so it says, how is multiplying fractions similar to multiplying whole numbers? And how are they different? Well, we didn't really multiply up here, though, did we? But we could have. I could have also, so the third way we could have done it, right, is I could have done 3 over 2 times 7 over 4, which would have given me 21 over 8, which is 2 and 5/8. So same question, 3 different ways we could solve it, right? So I think this is what they're asking about. So how is multiplying these fractions similar to multiplying a whole number? What do we do? So we multiply the same way, right?
I wasn't really here with my computer. It was giving me big problems.
Okay, so we would multiply the same way as we would a whole number. The only difference is we're going to multiply the numerators and the denominators. So we're going to do it twice. So the only difference is we multiply twice, because we're going to end up doing our denominator and our numerators. So not much difference. We just have to do it twice. All right, are we good? Or do I need to pause?
It's still freezing, but I'm going to rewatch the video when you post.
Okay. Yeah, I don't know what's going on. All right, so I'm going to flip it over for those of you that it's not frozen for. Is it frozen for everybody or just for Peyton?
Oh, it's frozen for me now.
Yeah, it's frozen for everybody.
Okay, how about now? Can y'all see the second page?
Yes.
We can. It's just like super laggy.
Okay. All right, well, if you can see the second page, so here you will have the conversion chart. On your test day, I will upload the conversion chart as well so that you will have it when you take your test, okay? But we're going to use that chart to convert today. So it says Heather needs to mail the package shown. The weight on the display is in pounds. The shipping company charges by the ounce. How many ounces does the package weigh? Okay, so I know you can't see it on my copy, but right here it tells me that it's 4 pounds, right?
The screen is frozen again.
Okay, I don't know what to tell you guys. I mean, I don't know what to tell you. Y'all are just going to have to listen and then watch the video. I don't know what to say. I didn't have that problem last period, so it's weird. I don't know why it's doing it. Okay?
It looks a lot better right now.
Okay, I don't know. So you'll just have to listen and then come back. All right, so it says, how many ounces are in 1 pound? You should have the book in front of you. If not, you're in Seesaw, and you can follow along with what I'm saying. Okay? So how many ounces are in 1 pound? What does my conversion chart say?
16 ounces equals 1 pound.
Yep. So that's what you're going to write for A. 16 ounces equal 1 pound. Okay, so that's number 1A. So if you're following along with your book, I'll just tell you what number it is so you can write it. So number 1A should say 16 ounces equal 1 pound. All right, so B is asking us what rate could we use to convert 4 pounds into ounces. Okay, so they're asking for our measurements up here. So our rate would either be 16 ounces divided by 1 pound, or you could do 1 pound divided by 16 ounces. Okay? Are we good on B?
I need some time to copy it down because I can kind of see it on the screen.
Okay.
Okay, I'm done.
Okay. All right, so C says use equivalent ratios to convert 4 pounds into ounces. All right, so we're going to rewrite it. So they want us to put ounces on the numerator, so that would be 16, and pounds on the denominator. So the first 2 boxes would be 16 and 1. Now, to get from 1 pound to 4 pounds, we're going to have to multiply by what? 4. So the next 2 boxes would be 4 and 4. So 16 times 4
is 64.
Yep, would give me 64 ounces. So the new rate would be 64 ounces for 4 pounds. So D says how many ounces are in 4 pounds? So 4 pounds is equal to 64 ounces. Okay, so that's what you should have written in D. All right, so now we're moving to the turn and talk, and the turn and talk says, how can you convert units within a measurement system? Okay, and there's a reason why they gave you that table, right? So the first thing we need to know is what units are equivalent. So when I say that, I mean, for example, 1 foot equals 12 inches. So even though they're 2 different unit of measures, they're still equivalent because we know that if I pulled a ruler out, 12 inches on a ruler is going to give me 1 foot, right? We know that those are equivalent. So that's what they mean, okay? The other thing we can do is we can set up, I know there's not an L there. We can set up equivalent ratios and rates, which is what we did here, right? 16 ounces, 1 pound, we multiplied by 4, so therefore we knew 64 ounces and 4 pounds was equivalent, okay? So setting up those equivalent ratios and rates will help us figure out what we need to do. All right, am I good? Can I move on?
I need a second.
Okay, you can see it now, Aiden?
Well, it'll freeze for a minute, but after you're done writing stuff, it'll like just pop out out of nowhere.
Okay.
Because I can't see what you're doing live, basically.
Weird. Okay.
I can kind of see it. I mean, like, it's starting to get kind of blurry because of bad nickel quality because of me. Well,
Okay. I gotcha.
bad internet.
Okay, everybody good so far?
Yes, ma'am.
Okay. Now we're moving to B. B says multiply the conversion factor by 40,000 pounds. So 1 ton in the first box, 2 in the second, and then in the third box you're going to write 40,000. Okay, so now we're going to simplify it. So move on to C. So the first box of C would be 1 ton. The denominator would be 2,000 times the third box would be 40,000 again. All right, so this piece is important. So you notice that we want to get rid of pounds so that we know what it is in tons. So the way to do that is you want to be able to set your ratios up to where I can cancel my unit of measure that I don't need. So if you noticed, I can cancel the pounds of the 2,000 and the pounds of the 40,000. I forgot a 0. And my pounds have now gone away. So now when I multiply, I say 1 times 40,000, which is 40,000, and 2,000 times 1, which is 2,000. So I end up with 40,000 divided by 2,000. And then my unit of measure is tons. So my pounds have gone away. So the reason why I'm saying this is important, so when you guys get to working on them on your own, you're not going to, the way you set them up is the way that you would end up canceling something out. Okay? So now I can use what I know about units of 10. So if I'm going to divide 20,000 into 4,000, I can cancel some of these zeros off, right? So I can cancel 3 zeros off the denominator and 3 off the denominator. So really I end up with 2 divided into 40, which is what? What's 2 divided into 40?
2. I mean, no, sorry, 20.
20.
20.
Okay, so that piece of art is 20 tons. Okay, so in D it says, how many tons of concrete are in 40,000 pounds? Well, there are 20 tons. So if I wanted to set that up as an equivalent ratio, right? I could write it as 40,000 pounds divided by 20 tons. So that would be that equivalent ratio. Or I could flip it, because remember in A it was tons to pounds. So I could flip it and I could put there are 20 tons in 40,000 pounds. So either one of those would be an equivalent rate. Okay, so the turn and talk is what I kind of just mentioned. So it says explain how you know how to set up the conversion factor. Well, I want to set it up to where I can cancel the unit that I'm not using any longer. So I want to set up the conversion factor so I can cancel the unit I no longer need. So for example, on the top one, we didn't need pounds. So I set up that ratio so that I could cancel my pounds out. Okay, and we'll look at number 3 and kind of do the same thing on 3. But I'll pause just for a second to give you guys some time to copy. Yep. So then my answer would be what?
450.
Yep. 4,500. Right? 2 places. So 1, 2. So there are 4,500 grams in...
You mean 450 since it's 4.5?
No.
Since you're moving it to the right 2 times?
Yeah, so 1, 2. Oh. Is it 450? Oh, am I moving it 2 times? How many zeros do I have?
3.
So I need to move it how many places?
3 times.
Yeah. That's why it's 4,500. Yep. Okay? So everybody good? Can you still see it, or is it frozen again?
It's been frozen.
I don't know. I don't know why.
It's stuck on the part where you can only see the turn and talk. You can't see any of the work we just did.
All right, what about now?
You can see it.
Okay.
Or I can see it, I meant.
Okay. Yeah, I'll just keep trying to reshare it. And so there you go. All right. So the important part, guys, is to understand how to set up that ratio so that you can cancel those units. All right. I'll give everybody just a second to copy that. All right, let me know when I can move on.
I finished.
You're good? Peyton, you're good?
Yeah, I finished.
Okay, awesome. All right, so number 4. So now we're going to have to do some conversions a couple times. Can you see the number 4?
Nope.
All right, I'll reshare it again. What about now?
Yes, ma'am.
Okay, all right. So a camel can drink 25 gallons of water in 10 minutes. How many cups of water can the camel drink in 10 minutes? So we're going to have to do some conversions because they want us to go from gallons to cups. Okay? So, on A, how many cups are in quarts? So look at your conversion table. How many cups are in 1 quart?
4.
4. Okay. And how many quarts are in 1 gallon? 4. Is there 4 quart? Yep. So there's 4 cups in 1 quart, 4 quarts in 1 gallon. All right. So we're going to use the 4 quarts in 1 gallon. I'm sorry. We're going to use the cups and the quarts to finish the table. Okay. So we know it's 4 and 1. Bye. We know it's 4 and 1. But if we only have 2 cups, how many quarts would we have?
0.
Not 0. To get from 4 to 2, what did we do?
We have to multiply.
We have to multiply by 2, right? To get from 2 to 4. But to get from 4 to 2, what did I do?
Subtract.
No.
Divide.
Yeah. So if I divide 1 by 2, what do I get? Can you guys see? Can you see it? If I divide 1 by 2, what do I get? Yeah, I get 1/2. Okay? But if the pattern continues now, if I go from 4 to 8, what do I have to multiply by?
2.
Yeah. So then I got to multiply the 1 times 2 and I would get what?
2.
Yeah. So if 4 cups is 1 quart, 8 cups is 2 quarts, what about 16 cups? How many quarts would that be?
4.
Yeah, 4. All right. So B says, how many cups are in 1 gallon? Well, we can figure that out, right? Because if 16 cups is 4 quarts, we know 4 quarts is 1 gallon. Right? So if 4 quarts is 1 gallon, this is B. So on B, the first box is 4, the second box is 1. So if 4 quarts is 1 gallon, we know that 1 gallon is how many cups? Am I frozen again?
Yeah, but then,
Yeah, I tried to refresh it. So if 4 quarts is 1 gallon is how many cups?
16.
Yeah, 16 cups. All right. So my conversion rate would be 16 cups. So on C, you're going to put 16 and 1 because we're trying to get rid of gallons. So 16 over 1 times 25 gallons. Okay? And then what happens? My gallons cancel. Can y'all still see it?
No, it's frozen.
But I kind of wrote it down since you were saying it out loud.
Right. I'm trying to say it out loud so you guys can see it. Alright, so what happens is I canceled the gallons and the gallons. So we just need to multiply 25 by 16. So someone multiply 25 by 16.
Equals 400.
Yes. So 400 cups. So if I wanted to rewrite my equivalent rates, right, I could say 16 cups divided by 1 gallon equals 400 cups over 25 gallons if I wanted to rewrite it. Okay? Alright, so you guys have a few more minutes. You have about 10 minutes. So I want you guys to work on your own. Okay? And then in about 8 minutes, we'll come back and I'll give you the answers, or someone will share their answers to make sure that before you guys leave, you know what you're doing. Okay? So take about 8 minutes to work on that on your own. I'm sorry. I said on your own. I meant check understanding. All right, anybody want to share out their answers?
Should I do number 2?
Yeah. What'd you get?
So I got 6 feet.
Yeah. How'd you do it?
So I looked on the conversion chart, and the conversion was 12 inches equals 1 foot. So I took that and I multiplied it by I'm sorry, I cannot think today. So I did
What am I trying to get rid of? I'm trying to get rid of the inches, right?
right.
Okay, so if I did 1 foot divided by 12 inches times 72 inches over 1, right? I could cancel my inches.
Yes.
So I get 72 divided by 12, which is 6 feet. Okay, so we will pick up. Okay, we will pick up here tomorrow. That we need to check it. Okay, because that was the bell. All right, guys. I'll see you tomorrow.
Bye.
Bye bye. See you tomorrow.